Hi students, in the previous class we were discussing about Biot-Savart's law. Now we are going to discuss about Amperes Circuital law. Now you know we have studied Gaussian law or Gauss theorem in electrostatics. Similarly, Amperes Circuital law is also used to find the magnetic field at a particular point due to a current carrying conductor. In Gauss theorem, you construct an imaginary surface known as Gaussian surface. Same here, the same way we use an imaginary loop, a closed loop known as the amperian loop to find the magnetic field at a point. Okay. Now the law states that the line integral of magnetic field around any closed circuit is equal to mu0 times the total current threading through the circuit. The line integral of magnetic field around any closed circuit or any closed surface is equal to mu0 times the total current passing through the surface. Now I hope you all are familiar with the integration method, and we use this symbol to show it is integral. Now what is the theorem saying? The line integral of magnetic field around a closed surface. So in order to represent the closed surface, we put a circle here. This represents line integral over a closed surface is equal to mu0 times the current passing through the surface. Now we are going to use Amperes Circuital law to find out what is the magnetic field produced by a current carrying conductor. So imagine you have a conductor, say A, B, and current is flowing in the upward direction from B to A, current is flowing through the conductor. So you know moving charge or current produces magnetic field, which means there will be a magnetic field around the conductor. So imagine this is my conductor, current is flowing in this direction, so definitely there will be magnetic field around the conductor. This green circle represents the magnetic field produced by the conductor. Okay, now what I am going to do, I need to find out what is the magnitude of magnetic field at a distance, say R, from the conductor. So what we have to do, we have to construct a closed loop. We have to construct an amperian loop. And by symmetry, the shape of our amperian loop will be like this. It will be also a, look, these 2 points are parallel, these 2 points are parallel, these 2 points are parallel. This is also parallel, which means there is a symmetry in our amperian loop. Now one thing which you have to keep in your mind while using Amperes Circuital law is, I told you the law states that the line integral of magnetic field around a closed surface, that is B dot dl, is mu0 times the current passing through the surface. Now in Biot-Savart's law also there was a current element dl, but that dl was the portion of the conductor which produces the magnetic field. So you have a conductor through which current is passing, then dl will be the portion of the conductor in Biot-Savart's law. But here there is a slight difference. Here dl represents a small portion of our amperian loop. Okay. In Biot-Savart's, dl represents the portion of the conductor, a small portion of the conductor, whereas in Amperes Circuital law, dl represents the small portion of our amperian loop. Okay. Now, so I told you current is flowing in the upward direction and field is around the conductor. If I want to find out what is the field at this particular point, what I must do, I can use the Amperes Circuital law. But direction, we have to take into account direction also, because it is B dot dl, B dl cos theta. So I must know what is the angle between B and dl when I am deriving the expression. So if I take this point, the field is going like this, which means field is going into the plane of the board. The plane. I will put a cross mark. Now I am going to take a small portion of my amperian loop dl. portion. Now dl is also like this, it is going like this, which means B and dl are parallel. So theta is equal to 0 degree. And applying this on this side, we get integral or the closed circuit B dot dl becomes B dl cos 0, which is B dl. Now you know field produced by the conductor at that particular point will be a constant value. So I can take B outside, we will get is equal to B into integral over the closed surface dl, which is equal to 2 pi r. And what did Ampere say? Integral B dot dl is equal to what? Mu 0 times the total current passing through the surface. So I can write the equation as B into 2 pi r is equal to mu 0 into I. Or the magnetic field at the point or at a distance r from the conductor is equal to mu 0 I divided by 2 pi r. This is how we find the magnetic field at a point using Amperes Circuital law.